Welcome everybody, Mr. Gazdan in Gazdonian Production Studios. It's 9:35 on a Saturday night. How cool am I? How awesome am I, right? So, here we go. Okay, now what you want to do is find the letter of your last name and find the number that corresponds with it. Okay, and then what you want to do is write it on the front of the page next to your name. So for instance, my last name starts with a G, that number would be 35. I then go here and I write that number next to my name and circle it. So please do that now. Plane flies overhead. It accidentally drops cargo without a parachute. The cargo free falls toward Earth. How far has it fallen? 9.7 seconds after it leaves the plane. Key thing, free falling, that gives us acceleration due to gravity. Okay, so we're going to know that acceleration is going to be, and here I have some pages from the reference table here. The front page of the reference table, acceleration due to gravity right here. 9.81 meters per second squared. So that's always going to be acceleration when anything's free falling, which is nice. So acceleration for that is 9.81 meters per second squared. Time is 9.7 seconds, and then what are we trying to find? How far? So distance. How far has it fallen is what we're after. So let's see what we have here. We can't use the delta velocity. We don't have that. If we don't VF, no, we use it with distance. It's going to be, we don't have final velocity. It's going to be the fourth formula. D equals VI. D equals VI T plus 1/2 A T squared. So VI initial velocity in the downward falling direction is 0 because it was in the plane, so that's kind of nice. So that drops out. 0 times T is 0, so it gives us D equals 1/2 A T squared. So it's going to be 1/2 9.81 meters per second squared times, what is it, 9.7 seconds. Square that. So what you're going to get will be 9.7 times 9.7 is 94.09. The units there will be seconds squared. I'm going to do 1/2 of that, 9.81 meters per second squared. And let's glurf up some units here. Okay, second squared over second squared, cancel. Okay, so I'm left with meters, which makes sense for distance. That's going to be fine. And then I do that math. That times 9.81 times 1/2 times 0.5. Answer is distance is going to equal 461.5 meters. The question does not say what to round to, so I just round to the tenths. You can't really get dinged if it doesn't say what to round to. You can't get dinged, but that's how far it's fallen, which is kind of cool. You know, it's very calculable if all the forces aren't acting on it, like wind or whatever. But number 2, Fred pushes a rock off a cliff. How long does it take to hit the ground? I think pictures really help. It's 1,200 meters. Let's see what we have here. So, how long? Distance is going to be D equals 120 meters. Acceleration we're going to know is 9.81 meters over a second squared. And we're looking, that's acceleration. We're looking for time is what? So we look at the formula again. I want D, this is an A. My A, that lowercase a is lame. And that D is kind of lame. Here we go. I need D, A, and T. And the only thing that's really going to have that is, again, that same fourth one. That same fourth equation. D equals VIT plus 1/2 AT squared. Distance, now I know the distance, 120 meters. VI, initial velocity in that downward falling direction, is 0. That's nice. Plus 1/2. Acceleration due to gravity. 9.81 meters per second squared, and the time is what we're after, t squared. So do 1/2 times this, and then bring it over to this side. So that is 4.905 meters per second squared. And if you keep change flip the units, you're going to have, just as an aside, the units will look like this over here. Meters times seconds squared over meters, they cancel. So my answer is going to be in seconds squared. 120 divided by 4.905 equals 24. I'll just write it as 46 seconds squared equals t squared. So I want to get t by itself, so I have to do the square root of both sides, which I'll just do the square root of that is going to be 4.9. So I can write I'll write maybe 4.95, and the second squared will just become seconds, and that equals t. 4.95 seconds. The answer for the second one. How long? 4.95 seconds. Okay. How far along are we here? 6 minutes. Pete pushes a box off a cliff. How far has the box traveled? 2.7 seconds after it's been pushed. That's Pete. That's a box. That's a cliff. That's it falling. Here we go. What are we trying to find here? We're trying to find... Okay, so we have time, 2.7 seconds. We have distance we're looking for, how far. Acceleration is 9.81 meters per second squared. We're seeing the same pattern, and again, without final velocity, we're still on this same formula here. D, where am I? D equals VI t plus 1/2 a t squared. I'm trying to find D. VI, initial velocity, is 0, 1/2, 9.81 meters per second squared. Time is 2.7 seconds squared. 2.7 times 2.7 equals 7.29. That's going to be seconds squared times 9.81 meters per second squared. And don't forget the half. The half, really, sometimes people forget about it when they get so caught up in everything else. Like taking care of the units here, which is going to be second squared cancel. I'm left with meters, and then I'm going to do that times 9.81 times 0.5 equals distance equals 35.8 meters. Okay, that's for the third one, 35.8 meters. Let me see here. Let's do one on the back. Let's jump ahead to one on the back. Let's do 2. A parachute jumper is falling for 10 seconds before she attempts to open the chute. How fast is she traveling? Okay, this is going to be a little different because now what we're trying to find will be something different. So let's see what we have. Time, 10 seconds. Anytime we think of falling, we know our acceleration is 9.81 meters per second squared. And we're trying to realize we're trying to find final velocity is question mark. The key thing is we also do know VI is 0. Because when you're playing, you're not falling down vertically. So that's key. That will bring us to this formula. no, it'll bring us to the third formula. I'm trying to think. I realized we don't have distance. I just saw VF there. See, even I'm kind of, my instinct was this. It's the third one. Final velocity, initial velocity plus acceleration times time. So it's a more straightforward formula. Final velocity equals initial velocity plus acceleration times time. So VF is initial velocity in the following direction is 0, 9.81 meters per second squared, times 10 seconds. Okay, and I just have to think about the units here 1 second, and what you do is go like this. What's going to happen is this second will cancel out with the squared, so I still have a meter and a second, which makes sense to me. Final velocity will be in meters per second, and 10 times VF will be 10 times 9.81 will be 98.1 meters over seconds. There you go. That's number 2 on the back. 98.1 meters per second. Okay. And let me do one more. Let me do 3. Young boy drops a coin off a building that's 55 meters tall. How long does it take for the coin to hit the bottom? So now I have distance of fall is a height of 55 meters. Acceleration is 9.81. See, you're going to get that in your head for sure. How long does it take? T equals question mark. I think it's the other thing we know. Initial velocity, 0. In that direction, in the vertical direction. Actually, in both directions on top of a building. So we're back to, let me see, I have D, I have A, I have VO, I have D, I have VI, so it's going to be this one here. Yet again, D equals VIT plus 1/2 AT squared. 55 meters equals 0 plus 1/2 9.81 meters per second squared times t squared. I'm going to be solving for t. Multiply that by 1/2 and then bring it over this way. So I'm going to get 4.905 meters over second squared equals t squared, right? Because I'm going to do that here, so it's going to cancel out. I'm going to cancel that out. The units, as an aside, will be keep, change, flip, as people say they love to do. Meters over second squared over meters. Okay, meters will cancel. I'm left with second squared. Oh, it feels so good to glyph, doesn't it? Holy cow. Glyph those units. Works out. So that's going to be 11.21, and it's going to be second squared equals t squared. To get t by itself, I have to do the square root. Square root of 11 is 3.3. I have to just write it 3.3, and the seconds will be squared. Seconds equals t. 3.3 seconds for this one. So that's all I'm going to do here because my time is kind of running out. I think I'm running out of space on this camera I'm recording on. So we've done this. The other ones are very similar in that. And get through them. Do these. If you need help, come see me. But, you know, do your best. Watch this video again. You need to know these. Watch the other ones. Know this stuff. Know it. Mr. Gazda, signing out.